I told everybody we were on page 36 some time ago, like about 5-6 minutes ago. All right, there's time to go. Transformation, we're going to verify now. Yesterday we simplified. Now we're going to verify, which means we're going to transform one side and leave the other side alone. And we're trying to transform one of the sides so that it matches the other side. So what you do is you transform one side of an equation. You use the basic trigonometric identities along with the definitions of trigonometric functions to verify trigonometric identities. Often, it's easier to begin with the more complicated side of the equation, that's almost always the case, and transfer that expression into the form of the simpler side. You can only change one side. Notice that is in capitals. If you mess around with both sides, you'll get no credit for your identity. You must leave the other side just like it started. Here are some guidelines for proving identities. It's usually best to work on the more complicated side first. You want to look for trigonometric substitutions involving the basic identities that may help simplify things. You want to look for algebraic operations such as adding fractions, distributing, factoring, etc. that may simplify the side you're working on, or that it will at least lead to an expression that will be easier to simplify. If you cannot think of anything else to do, change everything to sines and cosines. That's often a really good plan. Okay. Try multiplying both the numerator and denominator by the same trigonometric expression. Remember conjugates, pairs and stuff. Sometimes that could come into play. Always keep an eye on the side you're not working with to be sure you're working toward it. Don't be afraid to stop and start over if you don't seem to be getting anywhere. This is not a formula thing. Okay. It's not a 100% predictable pattern such as factoring is. It's different. Okay. So you have to practice doing them. All right, simplify. Some of these take quite a lot of steps, and you have to show the steps. You are not allowed to skip steps. If you skip steps, then you haven't verified and proven it. So verify that each. Don't assume I'm supposed to understand everything, that you're just going from, skipping 2 and 3 steps. That can't work. That does not work. It doesn't cut it. All right, so if I want to verify this one, which side would I work on, do you think? Yeah, the left. Okay, so I'm going to work the left. All right, so I'm just writing that I'm working that side. So what I'm going to do is I'm going to trade I'm not going to trade out anything that's already a sine or a cosine. Okay? I could change the cotangent to what we learned yesterday. It is the cosine theta over the sine theta. Oh, don't mind my crazy line there. Okay, and then it's minus secant theta equals negative cosine theta. All right, that's our goal, to get the left side to be negative cosine theta. The next step would be since you're dividing by a fraction, you multiply by the reciprocal. So I'll do the reciprocal of the denominator, which would be sine theta over cosine theta. And I still have minus secant theta. Don't know why I changed colors, I just like the darker blue. When I multiply sine times sine, I get sine squared. So I've got sine squared theta over cosine theta minus, and I forgot, why don't we change the secant to 1 over the cosine, which I could have done in the beginning. I don't know why I didn't do that. I meant to, but I didn't. It won't hurt anything, because now we have a common denominator, don't we? So since we have a common denominator, we can combine the numerators. Sine squared minus 1 over cosine theta. Now, this was the one Pythagorean identity that we talked about yesterday that I told you I had no problem with you knowing a manipulation of it. The Pythagorean identity was cosine squared plus sine squared equals 1. And I said it's okay with me if you realize or think all the time that 1 minus sine squared is worth cosine squared, or vice versa. So we can trade this with cosine squared theta. I asked you not to do that with the other ones. So I got cosine squared on top, cosine theta on the bottom. But wait a minute. Look up here. I must have just gotten tired after part of the day because I did this perfectly second hour and now I'm messing up. What's wrong with what we actually have in our... This is actually what cosine squared equals. Is that what we had in our numerator? Okay, it's the opposite, isn't it? So what should we change? We should put in front of here a negative sign. Okay? So it's the opposite of the cosine squared theta. Now, if you didn't quite follow just now where I got that from, if I were to factor out a -1 here, -1 times 1 minus sine squared theta would have been this. Okay? So all I'm doing is saying this then can be traded for cosine squared theta, and that would give me -1 cosine squared theta. Is that okay? All right, now what? Well, we're almost there. You see how we're getting towards the right? So we cancel out a cosine on the top and a cosine on the bottom. So you just cross out the little 2, and then you can say negative cosine theta equals negative cosine theta. So we have proven it, that the left and the right are equivalent. Okay, B. I'm gonna trade for sines and cosines. So I'm gonna rewrite the tangent as sine of theta. Oh, I am working the left. It's more complicated. Otherwise, I don't know what I'd write except 1 over the cosine theta on the right. Okay, so don't do that. Sine theta over cosine theta is the tangent. Cosecant is 1 over the sine. So this would be my first step. And do not rewrite the right side. You can keep in mind what that's equivalent to, but you have to rewrite it secant theta. Don't change it. I need to show my work, so I'm going to multiply by the reciprocal of my bottom fraction, which would be sine theta over 1. And then I'd still have plus cosine theta. If I multiply, I get sine squared theta over cosine theta plus cosine theta. Now, I can't add cosine theta to that because the denominators don't match. So let's show what we're going to do. I want to be able to add, so I need a common denominator. It would be cosine theta. So I'd have to multiply top and bottom here by cosine theta. Now I'm going to show this next step where I'm going to add since I'm going to have the same denominators, I can go ahead and show adding the numerators. Sine squared theta plus cosine times cosine, cosine squared theta, all over, the denominator would be cosine theta, equals secant theta. Now, on the left-hand side, what can I do for a trade? What does sine squared plus cosine squared equal? It equals 1. So we have 1 over the cosine of theta equals secant theta now. And that, the final thing to write is that you know this is worth the secant, so secant theta equals secant theta is your last step. All right, let's try another. Verify that each is an identity. Well, I've got a sum, I've got a product. Looks to me like I'm going to have to work on the left. So what do you think? Change these to their reciprocal, that reciprocal function. I'll leave this alone. So I've got 1 plus cosecant squared theta would be 1 over the sine squared theta. Then we have times cosine squared theta equals cosecant squared theta. Next, I would go ahead and multiply the fractions. So I'll have 1 plus cosine squared theta over sine squared theta equals cosecant squared theta. What's cosine squared over sine squared? It's one we want to learn. It's cotangent squared. 1 plus cotangent squared theta equals cosecant squared theta. Look in your Pythagorean identities. Look at your identities list. Isn't that one of them? I think it says cotangent squared plus 1 equals cosecant squared. So this is cosecant squared. Therefore, we're done. So cosecant squared theta equals cosecant squared theta. Number 2, I'm going to rewrite cosecant 1 over the sine. Oh, wait a minute. I don't know if that's the easiest side to work. This is a product, and this side is a sum. So I'm thinking this time we should work the right side, because a sum is a little more complicated than a product. All right, so I'm just going to rewrite the left this time. And I'm going to give myself some room, so I'm going to scooch it over here, else we're going to be crammed up. Okay, so cosecant theta times secant theta. Now I'm going to trade the cotangent for cosine theta over sine theta. Plus, trade for the tangent, sine theta over cosine theta. Rewrite the left side. Now, what can I do here so that I could add those fractions? Yeah, well, I have to multiply this one by the cosine and this one by the sine. All right, so I'm going to write that down. So I'm going to write cosine theta over sine theta, and I'm going to show that I'm multiplying the first fraction by cosine theta on top and bottom. I'm going to rewrite sine theta over cosine theta, and I'm going to show that I'm multiplying that fraction by sine theta top and bottom. Okay. All right, when I multiplied this fraction, I'm going to get cosine squared theta plus, I'm going to add, because my denominator is going to be just sine cosine. Sine times sine would be sine squared. Okay, what can I do for a trade? Cosine squared plus sine squared is 1. Bless you. 1 over sine theta cosine theta. We're almost there. Now, what you would need to show me is that you know that you could separate this into two fractions. 1 over the sine theta times 1 over the cosine theta. If you multiplied those, wouldn't you just get right back to what we had? Okay, so you can separate them. That's a property of fractions. Excuse me. And now you can verify that you realize the two sides are equal. So you have to write cosecant theta times secant theta equals cosecant theta times cosecant theta. And then you're done. Does anybody need this still? Okay. All right, number 3 on the back, 36B. What side should we work? Okay. And what can we do right away on the top? Trade for 1 minus sine squared theta equals what? Well, we're going to be done fast with this one. Cosine squared theta over cosine theta reduces to cosine theta. So this one was a quick one. I'm sure that's been your favorite one so far. All right, number 4. It's not really that bad. Let's trade tangent for sine theta over cosine theta. Let's trade 1 minus the sine squared for cosine squared. We can cancel out one of the cosines, and we're done. Sine theta cosine theta equals sine theta cosine theta. Party's over. All right, let's find some that's, the rest of these aren't going to be this easy. Okay. All righty now. Number 5. I need to be able to add these fractions, but they don't have the same denominator. So I'm going to rewrite the first fraction. Now we got t's and thetas instead of thetas. The first fraction I need to multiply by 1 minus sine t, top and bottom. I'm going to next write the second fraction. I have to multiply it, top and bottom, by 1 plus sine t. And what I'm going to try to get this side to equal is 2 secant t. Okay, I'm going to go ahead and distribute. I got cosine t minus cosine t sine t. Of course, the denominator is going to be the same on both fractions, which I'm going to continue combining my numerators. I could get my pen to stay still. So now I'm going to do this. So that's going to be plus cosine t plus cosine t sine t. In the denominator, if you multiply conjugates, the middle term drops. 1 times 1, 1 times negative sign, 1 times positive sign. Those are going to be opposites, so they wipe out. Last, you'll have sine times negative sign, so it's going to be minus sine squared t. Okay, now look at what you got in your numerator. What simplifies? What? There aren't any signs. The cosine t plus the cosine t we can do, which is 2 cosine of t. And then these are opposites, cosine sine, one's negative, one's positive. So those cancel out. Now remember our goal. We're trying to get 2 secant t. So I could trade the denominator, this 1 minus sine squared t, for a cosine squared t. Okay, now I can show that I can cancel out a cosine t with one of the cosines in the denominator. So what I've got here is 2 times 1 over the cosine of t. And so 2 secant t equals 2 secant t. Got it? We made this left side look like to be the right side. All right, I'll give you a little hint on number 6, unless somebody sees something right away. Can't add these. One's 4th power, one's a 2nd. Can't you do something with that? Can factor that, can I? That would be x squared plus 1 times x squared plus 1, right? So I got to factor this. It's going to be the tangent squared theta plus 1 times the tangent squared theta plus 1. So I could rewrite that as tangent squared theta plus 1 quantity squared. Or I could have traded these for secant squareds. Isn't this one of my Pythagorean identities? Look on the Pythagorean identities list. Look on your sheet. Tangent squared plus 1 equals secant squared. So secant squared theta, if you square that, or if you did secant squared times secant squared, you'd have secant to the 4th. Done. So literally, I could have actually eliminated this step. I could have done this is a secant squared, this is the secant squared, and then I could have written that. Okay, number 7. Oh boy, another one with addition. I'm going to work the left side. I don't know if I said that on the last one. Got to get common denominators. So I'm just going to rewrite the first fraction. I'm going to multiply the first fraction by the second fraction's denominator, sine x. Better put parentheses around that second bottom. And then I'm going to rewrite the second fraction. And I'm going to multiply that fraction by 1 plus cosine x, top and bottom. Okay? So let's simplify these numerators. Sine x times sine x, sine squared. Plus, I'm going to be adding because the denominators will be matching. And I'm not going to distribute this denominator right now. Okay, I'm just going to write the denominator as the sine of x times 1 plus the cosine of x. Now, obviously, I've done this stuff before, so I kind of see ahead that I probably don't want to distribute it. All right, because look what I want to get. I want to get the sine alone on the bottom. You see what I'm saying? This is 1 over the sine. So that's how I knew I probably shouldn't distribute. I'm going to want to make this go away somehow. So I'm going to see what I got. All right, in the numerator, I have sine squared x. Then over here, I got to FOIL this out. So 1 times 1. Okay, 1 times cosine, another 1 times cosine, so that's plus 2 cosine x. And then last, cosine times cosine plus cosine squared. I hope you kind of realize why I've tried to teach you how to quick FOIL when you have a binomial times a binomial. You can get it faster, you don't have to write so much. All right, now, let's look at this thing. What do you see that you might be able to simplify? Is there anything in there? Trade that for 1. Yep. You got a sine squared plus a cosine squared. So we can write 1 plus 1 plus 2 cosine x. And on the bottom, we have sine x times 1 plus cosine x. All right, I need to show 1 plus 1, of course, is 2. Okay, now I want you to look at this numerator and say, well, what can I do to help get myself simplified when my goal is to get to secant x? Oh, it's not 2 secant x, is it? I just lost what I was doing here. 2 cosecant x. What can I do here? Wasn't the strongest factoring issue that you ever had. You can factor this. Factor out a 2. Okay, 2 times 1 plus the cosine x. All right, so then your denominator is sine x times 1 plus cosine x. And all you have to do is show me that you can cancel out the 1 plus cosine x top and bottom. You can rewrite the 2 over sine x as 2 times 1 over sine x. And then finally, you've got what you wanted. 1 over the sine is the cosecant, so you've got 2 times the cosecant x equals 2 times the cosecant of x. That a good one? All right, number 8. This is our last example today. You cannot cross product. No. That would be working both sides. I need to pick a side. Which one has the worst denominator? Probably the right. I'm going to work the right. All right, so what I'm going to do is rewrite the first as 1 plus sine t over cosine t equals, I'll rewrite the second, and I got to decide something to do. Yes? Theta is a letter. Theta is just a Greek letter, so, well, I guess, yeah, I mean, if that's, I was asked if you can be writing theta here instead of t. Not really, but I'm not going to, that wouldn't be something that I'm going to, yeah, no, I wouldn't crucify somebody for that. No, not technically, because t is a different variable than theta, which would represent a different thing, but it's actually, the process, though, is absolutely the same. Okay, so I wouldn't be all worried about it. So if that's working for you better right now, that's okay. All right, so what am I going to multiply by? I'd like this denominator to be something else. And so I'm going to multiply by something that would transform this into something maybe I can work with. Well, if I multiplied it by sine, then I'd end up with sine minus sine squared, and that'd be kind of messy. So I'm going to multiply by the conjugate, which would be 1 plus the sine of t. And I have to do it to the top and the bottom. Now, you'll start seeing why I'm doing that in just a second. Because, all right, rewrite the left here. If I do that, and then I'll get cosine times cosine, cosine t times 1 would be cosine of t. Cosine times sine would be plus cosine t sine t. Maybe I shouldn't have distributed that. But I'll wait. Yeah, you know what? I can tell right now. If you didn't write this yet, I wouldn't distribute it. I would not distribute it. I got distracted there for a minute, my train of thought. But I'll leave it. I'll leave it distributed because I did it, in case somebody did. All right. You could leave it undistributed, let's just say. Now, the denominator. 1 times 1. If you multiply conjugates, remember what happens with the middle terms. They drop out. So 1 times 1 is 1. 1 times sine. 1 times negative sine. They drop out. And so minus sine times sine, which would be sine squared. All right, 1 plus the sine of t over the cosine of t. Now it's going to equal, let's see, let's trade the denominator, and I'm going to unmultiply by the cosine. Okay. What's our goal to find? We want this to be cosine t, so what can I trade 1 minus sine squared for? Cosine squared t. All right, so now I'm ready to finish off the problem. All I have to do is show that I can cancel out the cosine on the top with one of the cosines on the bottom, and the left side now equals the right side. Done. No. You will not be given something that can't be isn't a verifiable identity, because that would just be cruel. Because it would be very cruel. If there was no way to get there, to get this left the one side to equal the other side, then that would just be an exercise in futility. So, yeah. Okay, the assignment is to do the practice page. Wait, you got page 900 from the book, and I think we have this worksheet also for verifying, which is 37A. Regardless which one we do, you need to get started working on those, and I'll probably help some more next time I see you. We'll do some more that you would like me to help with.